Okay, in our previous video lecture, we looked at the properties of logarithms. In this video, we're going to kind of mess around with those properties a little bit. We're going to use them to change how things look, to come up with answers, etc. So basically, we're going to work with those properties. We're working our way toward making use of these properties to actually solve equations. So what do we know? Well, we know the properties from a previous video lecture. I've listed 9 here. I didn't list property 10, the change of base formula. We're not going to focus too much on 1 and 2. Those are kind of self-explanatory. And we're not going to get into 8 or 9 here a whole lot. These, again, will be used more as we look to solve equations. We're going to be focused on properties 3, 4, 5, 6, and 7. So the log base a of a to the r, or a to a real number exponent, is equal to r. A raised to the log base a of m is equal to m. The log of a product is equal to the sum of the logs. The log of a quotient is equal to the difference of the logs. And the log of a power is equal to the product of the power and the log. Those are our focus right there. So let's get into it, do some examples that kind of play with these a little bit or make use of these. If I can leave that high enough, I think I can get in what I have here, 1, 2, 3, and 4. So here we are, 3, example 1, use the properties of logarithms to simply simplify. 3 raised to the log base 3 of 18. Well, that's property 4. When you have the same base here that's in the exponent, and that's in the logarithmic exponent base, then out comes the argument. So this is 3. And the same thing is seen here in example 2. 2 raised to the log base 2 of negative 5. Well, out comes negative 5. And if you want to use your calculator to look at those, you can do that as well. You should get these 2 answers. Okay, examples 3 and 4, I've got them on the bottom of the page so that I can also have this up here, property 3. The log base a half of 1/2 to the 20th. Well, that's this property. Log base a of a to the r, out comes r. So out comes 20. The natural log, which has a base of e, base e of e to the 3rd, that's also property 3 right up here. The same base as you have the base of an exponent in the argument, and out comes 3. Okay, now let's take a look at some other examples here. So next up, we're going to make use of these properties. Use the properties of logs, or if you want to call them the laws of logs, either way, to find the exact value without a calculator. All right, example 5. Log base 3 of 24 minus log base 3 of 8. Well, when I have a difference of logs, I know that that's equal to the quotient. Okay, so log base 3 of 24 minus log base 3 of 8. I go back over to here. Log base a of m minus log base a of n is equal to log base a of the quotient. So let's put that property into play. This equals the log base 3 of 24 divided by 8. And this equals, of course, the log base 3. Well, 24 divided by 8 is 3. Well, the log base 3 of 3, and that's equal to 1. Okay. Example 6 here. The sum of 2 logs. Well, that's equal to the product of the arguments. Log base 8 of 2 plus log base 8 of 32 is equal to log base 8 of 2 times 32. Remember, the log of a product is equal to the sum of the logs. So we just use that one just backwards. Okay, well, let's see here. This is the log base 8. 2 times 32 is 64. And 8 squared is 64. 8 squared is 64. So there you have that one. Example 7 here. A lot of things going on in an exponent. 6 raised to the log base 6 of 3 plus log base 6 of 5. Well, this looks just like this. So let's rewrite this as 1 log base 6 of 3 times 5, which is 6 to the log base 6 of 15. Oh, that's just 15. Same base. That's in the base of the log in the exponent, and out comes the argument 15. Okay, let's change a little bit and let's do some other work. Write each expression as a sum or difference of logs. Express all powers as factors. So they don't want powers, they want to write those as products. All right, the log base 3 of x minus 1 times x plus 2 squared. Well, the log base 3 of a product is equal to the sum of the logs. So it's log base 3 of x minus 1 plus log base 3 of x plus 2 squared. Remember, a log of a product is equal to the sum of the logs. Now we have an exponent here. They want to express all powers as factors, so we know that can move in front. So this is the same as the log base 3 of x minus 1 plus 2 times the log base 3 of x plus 2. All right, that's example 8. Let's take a look at example 9. Now we have the log of a quotient. Log base 5 of the quotient x squared y cubed divided by the square root of z. A lot going on here. We know that the log of a quotient is equal to the difference of the logs. So log base 5 of x squared y cubed minus log base 5 of the square root of z. Okay, I got a sneeze coming on perhaps. Maybe not. Maybe so. We'll see. Let's see if I can keep going. Okay. Nope, there it goes. All right, let's move on. This is now the log of a product. Well, the log of a product is equal to the sum of the logs. So this is log base 5 of x squared plus log base 5 of y cubed. And I'm going to write the square root of z as an exponent. The square root of z is z to the 1/2. Whoops, I shouldn't have equals there. That should be a minus sign. Minus the log base 5 of z to the 1/2. Why? Because x to the 1/2 is equal to the square root of x. Those two things are the same. So I took the square root of z and wrote it as an exponent. Now I know that all my exponents can come in front, okay, because we want to express all powers as factors. We want all these exponents to be multiplication. So this equals 2 times the log base 5 of x plus 3 times the log base 5 of y minus 1/2 times the log base 5 of z. So there we've taken this expression and we have expressed it as a sum or difference of logs, and all of our exponents are products. No exponents here that were not moved over. All right, 3 more examples here. In these 3 examples, we want to write each as a single logarithm. So you'll notice back here in examples 8 and 9, we took a single logarithm and we expanded it. And we wrote it as a sum or a product of multiple logarithms. In examples 10, 11, and 12, we're going to do the reverse. We have several logarithms and we want to express them as a single logarithm. Okay, example 10, log base 2, just let me get my notes here. Log base 2 of x plus log base 2 of x minus 3. Well, that's equal to, this is the sum of logs, log base 2, and I'm going to write it with brackets, x times x minus 3. Just to be a little more clear, okay, for some clarity. So the sum of logs equals the product. If I'm adding two logs with the same base, it's the product of the arguments with the same base of one log. Here, I can do a little bit of work with this one. This is the log base 2. How about of x squared minus 3x? All right, we've gone from two logarithms here. We've expressed it now as a single logarithm here. Example 11. Again, I have two logarithms. This time I have subtraction going on. I also have a number in front, which I need to pay attention to. 3 times the log base 6 of z minus 2 times the log base 6 of y. Well, again, this in front, remember we can move an exponent from back to front. So this is the log base 6 of z cubed. Oh, and same thing here. I got an exponent, I have a number in front here. I didn't notice that. Is equal to the log base 6 of y squared. Now I have a difference of logs. I know that is equal to the quotient. So this is the same as 1 logarithm log base 6 of z cubed over y squared. Okay, I started with 2 logs, and I now have a single logarithm, which is what I was looking to do. Final example, example 12, has a little bit more going on. We can break this down again step by step. The natural log of x minus 2 plus 2 times the natural log of x minus 5 times the natural log of x plus 3. Oh my goodness. Well, let's first make a move here with these exponents. This is the natural log of x minus 2 plus the natural log of x squared minus the natural log of x plus 3 to the 5th. Now, by the way, if you want to write this one here, for example, as the x squared, that's the same thing. It's not a change in what you're doing there. Sometimes you'll see it in both ways. All right, this is a sum of logs. We can write that as a product with 1 natural log. This is the product of, I'll tell you what, I'm going to use brackets so I don't lose track of my parentheses. I'm just going to write it the product first. This is x minus 2 times x squared. So this is the sum of logs. That's equal to the log of the product minus the natural log of x plus 3 to the 5th. I'm not going to mess with that yet. This can be simplified. This is the natural log. I can do the math here. This is x cubed minus 2x squared. Okay, so that's the natural log of x cubed minus 2x squared as I multiply and distribute, minus the natural log of x plus 3 to the 5th. This is a difference of logs, which is equal to the log of the quotient. So this is the natural log of the quotient, x cubed minus 2x squared divided by x plus 3 to the 5th. And I'm going to leave it just like that. I think that's fine. In this case, I took three logs, or in this case, natural logs. The goal again, write it as a single, and here's the single. A little messy, but we're not too worried about that. That comes down to a single log. All looks good. So there you have it. Lots of kind of practice working with those properties of logarithms. And upcoming in our next set of video lectures, we're going to talk about using all these properties so that we can actually solve equations.